Okay, I have done work on the CPU board. I've replaced all of the sockets. I washed it. I actually sprayed it down with vinegar and kind of scrubbed with a toothbrush to remove any of the kind of corrosive stuff on the traces and whatnot. And you remember up here it was pretty bad, right in this area. And just vinegar is a light acid. It's not very aggressive. And it works well for just cleaning off traces. The surface corrosion, it's good for getting surface corrosion off. So we got all new sockets. And the board's looking pretty good. Yeah. So it's looking really good. So next is to move on to the video board. I'll repopulate all the parts in here, and then I'm gonna move on to the video board, or the AVG board, and do the same treatment. New sockets. Thankfully there's less sockets on that one, so we'll go ahead and do that. Okie dokie. Now I have the AVG board reconditioned. I got new sockets in it, all new sockets. And this guy right here, this 40 pin socket, is almost kind of like an Atari style socket. But those, I got a bunch of them in a lot. And those are good for this kind of stuff right here, where you're plugging in these headers into something. These sockets are good for that. So I'm glad I do have those, and I'll use those exclusively for if something like that's being plugged into a socket. But as is with all of my Vector repairs, from this moment on forward, I bought in some stuff, and this is routine part of my service from here on out. The 78 and 79 15s will always be replaced. New caps, of course. I got it recapped. And all of the TL082 op amps, there's 5 of them on Star Wars, 1, 2, 3, 4, and 5, are all removed and socketed and replaced with brand new Texas Instruments TL082s. That's just part of the service from here on out. So this guy's good to go now, and I cleaned up the back of it really good. This solder I used leaves a little bit of a residue. I ran out of my solder, so I'm using another spool now, and it's a more aggressive flux in the solder. I like the way it solders, but it does not clean up as good. It's not bad, but it leaves a slight residue behind. So I'll probably brush that again. But I do like the way that it solders better, but it's harder to clean up. But so I'm going to repopulate this, and we'll rehook up and fire it up, and now we can move on to troubleshooting now, because we know everything's solid. So let's go ahead, hook everything back up. Okay, we are all hooked back up after all the socketing was done. And we're doing it's exactly the same thing. The stars are only over in one of the 4 quadrants. There's 1, 2, 3, 4 quadrants basically, and we're only having stars in one of the quadrants, which is weird. and there's no TIE fighters. There's no bad guys. Which I'll let's fire this up. Let me set this up, and I'll show you exactly what's going on and what's not happening. I'm going to turn off some lights so it looks better for you. Okay. And I will go ahead and start this thing up, and you'll see there's no game going on. No TIE fighters, no action. So let's go ahead and coin.
The force will be with you, always.
Okay, credit is in.
Red 5 standing by.
And we'll just wait for it to count down, and you'll see there's no game, there's no enemies. This is it.
Red 5, I'm going in.
And here it's just frozen. You know, Luke announces he's going in, and this is it. Just it freezes right here. So, yeah, this is it. I'm kind of wondering if this is, I mean, this, kind of wondering if this is a ROM problem, because it's like the program's not advancing, or it seems like he would still, even if there's missing stuff, you might still go down into, well, you know, this is weird because a self-test would tell you if a ROM is bad, right? This is, yeah, I don't know. I'm just going to have to experiment around on this and find out what, I mean, the 3D shapes and stuff is the math box type stuff. Is this an AVG problem, or is it a main board problem? I kind of think it's a main board problem. It's really hard to say. But if I had to guess, I would definitely say this is a main board issue. And I kind of want to verify the ROMs and make sure that the ROMs are good. There might be bad ROMs on this thing. So I think, you know what, that's a good place to start for elimination, is just dump the ROMs, compare them against ROM ident, and compare them against MAME, and see if they're actually the right files. So let's do that first and foremost. Now let me put this all away, and I got to put this all up and then go through and, you know, get my programmer and stuff out. So I'm going to go ahead and do that, and we'll be right back. Okay, this is kind of strange. I don't know if this has anything to do with anything, but it is weird. Here we have a ROM which says 103. Okay? This is not in MAME. The ROM that is in MAME is 203. There is no 103. And what's really curious about this is right now I have loaded up 203, right? And the sum check of 203 is 73 DD. Now keep that in mind, 73 DD. I'm going to go ahead and load. Oops. Let's exit. Let me go ahead and load RAM from master. This is 103, and you'll see 73DD. I just want to verify against the RAM. Okay, it passes. 73DD. Right? Now let's go ahead and load up from file 203. And watch the sum check for 203. Okay, 73DD. It's the same checksum. Now we go and verify ROM 103 against this, and it fails. Now yes, the data can add up to the same sum check, but be positioned different in different areas of the ROM, which is weird that this is like this. I don't know, this is strange to me. This is not in MAME. It's got the same sum check as the other one, but it doesn't verify, which means that this is organized different than 203. What's different about the boards? You know, I don't know. I know that this board has some jumper on the back, and I wonder if that has anything to do with it. I really don't know. So anyway, I'm going to burn a 2764 with 203. I'm going to burn that just to have, and I want to plug it in and see if it makes a difference. I'm going to use 203 and see what happens. All of the other ones, I haven't checked this guy yet, 105, but I'm going to go ahead and burn a 203 and then check this guy, and then we'll hook everything back up. Okay, interesting turn of events. This ROM did not verify. Self-test didn't say it was bad, but it did not verify to 105, so I am currently burning 105 into a 2732. So that might have something to do with it. I did program this guy right here with 203, but I don't think that's going to make a difference. So, yep, and I am going to do the 4 82S137s. I'm going to verify those guys. Verify that those are right. And then we'll move on. So after this guy burns, I'll be back after testing those 82S137s. We'll be ready to hook back up. This might be the whole problem right here, is that ROM does not verify to what it's supposed to be. So it's kind of a big deal. Okay, something very peculiar was just going on. This was the original 105 ROM, remember, which did not verify to 105 in MAME. Did not. I had burnt a 105, remember I burnt a 105 according to the MAME file, put it in here, and it would not work. It would just give me a vector generator error when I put it into test. Now I took the one I burnt out and put this 105 back in, and it started working again. So I think what we have here is a combination that is not in MAME, Remember, 103 is not in MAME, and this 105 is not the 105 that is in MAME. So I need to dump this guy right here and save it, because it goes along with this file. And you'll notice, I don't know if you did notice or not, but this has a big jumper on it, and it's a factory jumper from this ROM. No, this ROM. One of the address bits, I believe, on this ROM is being addressed by a chip way up here, and there's a blue wire jumper going on the back of the board like that, up to this area somewhere. So I think what we have here is something that is not in MAME. So this hardware revision, or this hardware revision, I believe, is not in MAME. So I'm going to document. I'm going to keep this 103. I did dump 103, and I need to dump this one and put them in a separate folder for Star Wars Revision 2. I'll call. I don't know. I'll put a little text file in there explaining what's going on for my own, for my own keeping, because this is not in MAME. So yeah, another one. Every now and again I come across something that's really strange like this, that makes no sense. Yeah. Anyway, we're doing this still. And I will tell you, remember I told you that there are two Star Wars board sets in this job, right? I took the other CPU board because my hunch is the CPU board has a problem. I think the analog vector generator is fine. If it had an error, it would have told me an error, I believe. Maybe. Anyway, I suspected that this board is the problem. So I took the other board that's with this job, and I hooked it up. And it came up with an error, and it turned out that this ROM was no good on that board. So I reset all of the chips, and I put a new ROM in right here on the other board, and it came up and it played perfect. The stars are right, the enemy fighters were in there good and everything. So the other CPU board is good, which is awesome. And it verified, it tells me that this board is the problem. So, yeah. And I read a bulletin. I read a Star Wars bulletin that said, don't use AMD RAM right here because they'll test good, but they're not good, right? When the game's playing, it won't be good. So I'm kind of wondering if one of these is a little funky maybe. So I think what I'm going to do is I'm going to throw some 6116s in here just to see if that might be an issue with those stars. I doubt it, but let's just do that to eliminate that as a possible issue. Alright, I'll be right back. Okay, I'm going to go ahead and turn it off. Okay, it is powered off now. And I'm going to remove these two RAM chips. Okay. I'm going to put in some 6116s here. And then fire it up and just, S's and G's. Just to eliminate this. I doubt that this is an issue. Nope, same problem. Okay, well we know that that is not the issue because it's doing the same thing. So, I got it turned off. And I'm going to put my RAM, my new RAM back. 6116s. Okay, put the old guys back in. Okay. And I also did verify all of these PROM chips, and they are good. So, software's all good, all of that kind of stuff is good. Let me go ahead and turn it back on, I guess. So what I'm going to do is I'm going to just take some time now, and I'm going to look at the schematic again. For the CPU, I'm honing in on the CPU board because I know this is the problem. Hands down, I know that this is the issue. So what I'm going to do is I'm going to hone in on the schematic because it's pretty well descriptive, you know, about what could be the issues. I'm just going to kind of look at it, and because it's labeled really well. Everything is really well labeled on that schematic. So I just want to look at it. I want to go over it and see where this might be. I know there's a section on the CPU called pseudo random number generator. You know what though? I don't think that has anything to do with it, because this has to do with all of the TIE fighters and everything else too, and all of that. So it's got something to do with that. So yeah, that's a good clue. There's no enemies and there's no TIE fighters. You don't go into the Death Star. So the Death Star's not there. The TIE fighters and stuff aren't there. So I will go ahead and, with that in mind, look over that schematic on the CPU PCB. And I bet you there's something on there that'll point me right in the right direction. So let me go ahead and start looking at that, and then we'll go over the schematic together. If I find somewhere that looks like a promising place to start looking, I'll let you know what I find. Okay, and I have put together all of the schematic sheets for the main PCB on Star Wars. There's probably about 10 of these. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. Yeah, so got them all together. Nice big sheets. So I'm going to go through these. I don't think this has anything to do with my problem. This does not have anything to do with my issue. This does not have anything to do with my issue. Coin door tests. Nope, this stuff does not have anything to do, I don't believe. Matrix processor, data selector, matrix. This could be an issue for sure. There's a lot of arithmetic on this. As when I was putting these together, it's kind of the CPU board. Normally with these things, you have the CPU, which does all of the arithmetic functions and stuff like that on a board. This board is different. This board is like a CPU within the CPU. It has its own all kinds of arithmetic logic. It has dividing, subtracting, addition, and multiplication circuitry on this. So it's like one big math box. It's actually kind of complex, but cool. So I'm going to be looking at all of that math stuff. Differential latch, adder, divisor, inverting latch. This stuff will have to be looked at. Dividend latch, dividend shift register, divider control, divider clock. I'll look through this stuff. And accumulator, shift register A, register B. See, this is like a CPU within the board itself. It has its own registers. It has a serial subtractor, serial multiplier, accumulator. So I really don't think this, I'm going to set this one aside for now. This is where I'm going to start, is with these 3 sheets. And we'll just start with this one. We'll start looking at the divider clock, and we'll just move on. And I'm not going to do anything very labor intense just yet. I'm going to probe all of these signals and make sure that they're present and they look how a digital signal should look. That's all I'm doing right now, is I'm going to go through and make sure that signals are there. Because this is a pretty catastrophic failure with no enemy fighters and stuff. I suspect that we're going to run into a major problem. So, you know, something's going to be stuck. Something's going to be high all the time. Something's going to be low. Something's going to be floating. You know, that's what I'm looking for right off the bat. So, let's get to it. I'm going to fire this thing up, and we'll get the scope and start probing these signals on these 3 sheets. Okay, guys. I am on the correct path right off the bat with the first sheet up here. These 299s in this box, this is where I started, and this was all looking okay, and I moved down to this box. And these are Ls299 shifters, and they get all of these inputs here. These are inputs. And basically what's happening is this one is shifting. This one is outputting this one and telling this to shift. These are all the control signals. And this is inputting. And it's for serial. I'd have to look up the data sheet on this. These are inputs though, I know that. This one looks like it's not outputting to anything, which is strange. Huh. QA, QH. This one is outputting serial data, which is telling this thing to shift left. But where's this shifting to? There's the outputs right there, and they're not doing anything. I don't know. I don't get this. But anyway, what I'm looking at is there are no inputs on this at all. And I'll show you that. This is 3N, which is one of them. Let's look at this one first. This one right here is 7M, which is way up here. And if we look up at my scope, I'm going to go through and do the control signals on 1 and 19. 1, 19, looking good. And then I got control signal, oh, 6 megahertz is the clock on pin 12. 6 megahertz. And we've got a signal on an enable signal, which are both enable low on 2 and 3. So there's 1 and pin 3. So we have our enables and everything, but these are the inputs. Here's 7, it's just floating. 13, floating. 6, 14, and 5. So 6, 11, 12, 13, 14, and 5. You get the picture. They're all floating on both of these guys. So I moved over to this guy, this latch, dividend latch, right? It's a couple 374s, and it gets information right from the data bus. And you have these 2 signals here that control this latch. You have DVD DM and DVD DL. That's H. DVDD high, DVDD low. Okay, And then these two signals right here are output control on 1 and 11. So let's look at these two data latches, which are 374 here and here. These two guys. I'm going to do first, this is pin 1, this is output control. This is, let's... Sorry, I could not interrupt that. Anyway, let's look at all of the inputs. These are straight from the data bus. Okay, here's an in. The data bus looks funky, but what it is it's tri-stated until it's enabled. It's very strange. I've never really seen it quite like this, but yeah. That is regular data bus, huh? Quotient shift register. No. No, this is a separate data bus, I believe. DB is coming from over here. These shift registers. I'm going to look at this box. Let's look at this box right here. I know I'm kind of jumping around, but this stuff, this is not the main data bus, because that looked weird to me. It's tri-stated too often. It makes sense. These are what are feeding that. This is not the main system data bus. This should have another name. They should have named this different. But and maybe they call the main data bus. Maybe it's buffered data bus or something. I don't know. But yeah, that was a little confusing. I saw those inputs to these latches, and I was like, that doesn't. A regular system data bus is going to be way more busy than that. But yeah, so this makes sense. So let's look at this, and we will. Oh, let's just look at these 244s. That'll tell us that these are working. So yeah, let's look at, what is that? 4J and 4K, which is here and here, 4J and 4K. So let's do this. I'll come up here, 4J and 4K. We'll just take a look. 244s. We'll look at all of the inputs. That's an in. 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 Input. 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 And input. No, that's not an input. Okay, let's move on to the other one. That was an enable. Okay. Input. I'm just going through all of the inputs on these two guys. Okay, does this one do anything? Because this is an input. It's 4J. Pin 11. That is the most significant bit, so that might stay low. I don't know. It's not really surprising to me right now. that this guy's low all the time. It very well could be. Okay. Now let's look at the control signals to this guy, which are common on pins 1 and 19. So that's the input, or that's the control signal. That's the enable, if you will. So our enable is good. Let's look at the outputs. And you'll see this is tri-stated until it's enabled. That looks good. Tri-stated until enabled. That's how a 244 works. Looks good. Okay. Tri-stated until enabled. Okay. Alright. You going to do anything? Yep, there we go. Okay. And this guy. Yeah. Okay, there you go. You gotta show me something. Okay. Okay. Cool. Yep. Okay. These seem to be working fine. These seem to be just fine. So, okay, we are good for right here. We've got our signals coming over to here. And we looked at that. We looked and we saw those. We saw those tri-stated signals coming over here. Now let's look at these guys again. These are the 374s, and let's cut right to the chase. 374s right here and right here, right? 4L, 5L. Yeah, these two guys right here. Let's just look at the clock, and you will see there is no clock on these. No clock. No clock. We have output enable. We have no clock. So we have no clock, we have no output. We have absolutely no output on these. So, yeah. So what we're going to have to do is I need to go to decoding, which I do have the decoding schematic, and I need to find these two signals right here, DVD D high, DVD D low. So let's get to that. You know what? That makes about a 35 or so minute video for part 2. I'm gonna stop, I'm gonna upload, and we'll move on with decoding on Star Wars Part 3.